In this tutorial, we will see how to develop a C-chart. C-charts are used to monitor the number of defects per item. When to use a P-chart and when to use a C-chart can be confusing. You use a P-chart when each item is categorized as either good or bad. That is, acceptable or rejected. You use a C-chart when an item can have more than one defect and therefore you're counting the number of defects each item has. For example, doing a final inspection on a widget and either shipping or discarding the widget would be monitored using a P-chart. On the other hand, doing a final inspection of a spool of heavy wire and counting the nicks on the wire would be monitored using a C-chart. The formulas are shown on the slide. The center line on a C-chart is just C-bar, the average number of defects per item. The first formula is for the upper control limit and the second is for the lower control limit. Because these formulas are approximations, it is possible that the lower control limit will be computed to be a negative value. When this happens, use 0 as the lower control limit. Also, use a z-value of 3 unless instructed otherwise by the problem you are working. Rolls of wire for electrical transmission are monitored for nicks using a C-chart. 20 rolls have been checked and the number of nicks per roll is shown on the slide. Plot the values on a control chart using 3 standard deviation control limits and determine if the process is in control. Between the 20 samples, there are 65 nicks. That is an average of 3.25 nicks per coil of wire. Plugging that into the formula gives us an upper control limit of 8.658 and a negative lower control limit which we make 0. The slide shows the resulting control chart. It is not symmetric because the lower control limit was changed to 0. Nothing is above the upper control limit and it's not possible for anything to be below the lower control limit of 0. So, the process appears to be in control. Large spools of cold rolled steel are monitored for defects using a C-chart. 20 spools have been checked and the number of defects per roll is shown on the slide. Plot the values on a control chart using 3 standard deviation control limits and determine if the process is in control. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. Between the 20 samples, there are 182 defects. That is an average of 9.1 defects per spool of steel. Plugging that into the formulas gives us an upper control limit of 18.150 and a lower control limit of 0.050. The slide shows the resulting control chart. This time, the lower control limit was positive, so the limits are symmetrical. No points are above the upper control limit or below the lower control limit, and there's no pattern, so the process is in control. If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.